Hello everyone, today let's solve the problem number 138, copy list with a random pointer, right? So you can just go through the question here and try to understand the question with the examples that they have given. So I'll just summarize the question so that it will be easier to understand, right? So what the question states here, we are given a linked list where each node contains a value here. We are given a linked list where each node contains a value val, val, and a value val and 2 pointers. One is next and one is random. So we are given a linked list, again I'm telling, where each node consists of a value val and 2 pointers, nothing but next and random. Next points to the next node in the list. Just keep this in mind. Next points to the next node in the list, and the random points to the random node in the list, or it might point to null as well here. So we are given a value val, and also we are having 2 pointers. They have given us 2 pointers. One is next, which points to the next node in the list, and another one is random here, which points to the random node in the list. Random node in the list, or it might be null as well. That's what they have given in the question. So we need to create a deep copy of the linked list. That's what they have asked. We need to create a deep copy of the linked list. A deep copy means each node in the copied list is a completely new node. Here, this is simple. Each node in the copied list is a completely new node. This one we have to keep in mind. And the structure, that is next and the random pointers of the copied list, should match the original list. So this is very important. The structure next and the random pointers of the copied list should match the original list. First one was each node in the copied list is completely new node, that we know now. The structure next and the random pointers of the copied list should match the original list. And finally, none of the nodes in the copied list should reference nodes in the original list. So just keep this one in mind. None of the nodes in the copied list should reference nodes in the original list. So this is the question that they have given. I hope the question is completely clear. You can see here, head they have given here. So this is completely new nodes, right? So we have to create a deep copy of the original one, right? So here you can clearly see the same thing: 7 null, 13 0, 11 4, 10 10, 1 0. So same output but completely new nodes. That's what we have to do here. So the output they have mentioned. Same goes with second example as well. 1 1 2 1, new nodes. So here as well, same thing, right? So I hope the question is completely clear. First, let's discuss the approach. Then let's discuss the edge cases one by one, and then finally write the code and discuss the complexity of the code that we have written. As usual, let's start with the approach initial. So the approach that we are going with here is we'll be solving this problem using the basically hash map. I'll just say why we'll make use of the hash map. Why we are making use of the hash map here? To map each node in the original list. To map each node in the original list to the corresponding node in the copied list. Just give me a second here. Yeah, to the corresponding node in the copied list. So we'll just be making use of the hash map so that to map each node in the original list to its corresponding node in the copied list. You'll understand this one while we write the code clearly. Let's discuss the edge cases one by one here. So let's discuss edge cases one by one here. So the first edge case here is if the list is empty. So the first one is if the list is empty. When the list is empty, that is nothing but head is null, then we have to return null, right? So suppose here head equals, let me consider empty, this one output, yeah, I'll just consider this one output null here. We have to return null, or output has to be empty array here. So what's the condition here? When the list is empty. So this is the first edge case that we are dealing with. Second edge case here is when the list has only one node with no random pointer. Input, suppose if we can consider like this, right? Head, I can just give here 5 and null here. This is fine. So the output will be here. Output will be 5 and null as well. So what's the condition here? We are going with when the list has only one node with no random pointer. When the list has only one node with no random pointer. You can clearly see here. When the list has only one node and no random pointer. So this is for the second edge case. Let's move on with the third edge case, right? So third one is if the list has nodes where all the random pointers are null. Here all the random pointers are null. Suppose I'll just consider one good big example. Let me give here 1 comma null, and same thing. All the random pointers has to be null, right? So here random pointer, second one, this one also 2 comma null. Let me consider 3 comma null. I can consider any. Suppose just consider here until 3 comma null, 4 comma null. Here again let me consider 1 comma null and 2 comma null here, right? So sorry, let me close this one. So the output will be same as this one. The output will be same as this one. It will be same thing. I don't have to write this one again, right? The output, I'll just point this one. The output will be same as the input. So this is for the condition if the list has nodes where all the random pointers has null. When list has nodes, when I'll just give here when all random pointers are null. This is one edge case. And let's move to the final edge case or the fourth edge case here. Fourth edge case would be if random pointers form a loop, right? If random pointers form a loop. Random pointers form a loop or point back. So let me consider the example head. Let me give here 1 or let me do one thing here. Let me consider here different example. I'll just give here 3 comma 1, 1 comma 0 here. This will be the input. Output will be same thing. 3 comma 1 and 1 comma 0 here. So this is for the condition when random pointers form a loop, right? That's what. So these are the 4 edge cases that we have to keep in mind. First thing is when list is empty, right? The second one is when list has only one node and no random pointer. And the third one is for when all the random pointers are null here. You can clearly see. And the fourth one is for this one, when random pointers form a loop or point back. You can clearly see here, right? So the output would be same. Here, these are the 4 edge cases that we need to keep in mind. So let's start writing the code and finally discuss the complexities of the code that we have. So let's start writing the code. So first thing, for the edge case, this one we have already discussed. Basically, it states that if the original list is empty, we have to return null, right? So let's go with the same thing. If the original list is empty, we have to return the null here. Nothing but If not of head, then we just have to return null here in this case. So this edge case we have already uh, seen, right? So let's go with the step 1. We have to create a hash map, hash map to map the original node to the copied nodes, right? So I'll just go with simple. Let's create a hash map here. This is fine. The next step here, why we are creating this hash map, basically to store the original node to the copied node, just to map the original nodes to the copied nodes. Just keep this in mind. Then we'll be making use of the pointer to traverse the original list. So I'll just make use of current pointer here, which points to the head. This is fine. So now let's traverse the list and create a new node for each original node. This we have already discussed. For each original node, we have to create a new node. That is the reason we are making use of the hash map. Now let's traverse the list, and for each node, let's create the new node. This is simple. Let me create while loop here. The parameter current here. Let me make use of set map.set current and new node of this one, value of the current. So this is fine. We are just mapping the original node to its copy. That's what we are doing here inside the while loop, right? So finally, after mapping the original node to its copy, we have to move to the next node. This is simple, right? Just initialize current to current dot next. So this is it. So let's move on to the next step. Nothing but we have to update the next and random pointers for the copied nodes. That's what they have given in the question. Strictly they had mentioned we have to update the next and random pointers for the copied nodes, right? Initially, what shall we do? Let's reset the pointer to the head of the original list. What we are doing here, let's reset the pointer to the head of the original list. Current equals head. Let me give here. This is simple till here. So I'll just make use of the simple while loop here, while of current. Let's set the next pointer of the copied node. So I can just the value by making use of the get property, right? Get of current dot next here. It might be the same map dot get of current dot next, or it might be null as well. So I'll just give here. Or did I make mistake here? This one I have to close here. Sorry. This is fine. Or it can be null as well. We know this. And we have to set the random pointer of the copied node as well. We have to set both. We have to set the next pointer of the copied node, as well as we have to set the random pointer of the copied node as well. So I'll just give here same thing, map.get of current. This one will be same. Instead of the next, we are going with the random. In the question they have mentioned we have two pointers. One is next and one is random. If you remember the question properly. So we are just setting the random pointer of the copied node. So I'll just give here same thing, similar to the previous line. Here this will be current dot random instead of current dot next, or it can be null as well. I hope this is completely clear. Here within the final within the while loop, this is the last thing. Then we have to move the next node to the original list. So I'll just set this one to the current dot next here. I hope this is clear. This is fine. And finally, let's come to the last step. Nothing but we have to return the copied node, nothing but which is mapped from the original head. This one we have discussed. So we have to return the copied head, right? So just we can get the value from by making use of the get property. So I'll just give here. Let's just return the copied head. This is it. So let me format the code once and let me hit the run button. So you can clearly see the sample test cases are getting passed here. Let me hit the submit button now. So you can clearly see all the test cases are getting passed here, right? So I hope the solution is completely clear. Then let's quickly discuss the time complexity and the space complexity of the code that we have written here. So the approach that we went with here is map, hash map, or the map. You can clearly see here, right? Uh, so the overall time complexity here would be big O of n. Why the overall time complexity here would be big O of n? We are traversing the list twice, once to create the node and once to update the pointers. You can clearly see here. Once to update the node and once to update the pointer. So overall time complexity here would be big O of n. And what would be the space complexity here? Overall space complexity would be here big O of n as well. Why? The hash map uses extra space that is proportional to the number of nodes in the list. So the overall space complexity would be big O of n as well. So I hope the solution is completely clear. For now, this is it. Thanks for watching.